Welcome, AP Psychology students. Today we're going to learn a little bit about neurotransmitters. Promise it's more interesting than it sounds. So, what is a neurotransmitter? Well, you break it down, neuro, meaning part of the brain, and then transmit to kind of carry back and forth. So neurotransmitters are actually the chemicals that allow neurons in our brain to communicate. So they're not sending letters to each other. They're communicating via these chemicals, and we call them neurotransmitters. So they get sent. If you kind of remember back from our discussion of the neuron, the axon terminal is going to release the neurotransmitter across a synapse, a little gap between the two neurons, and then the dendrite of the next cell is going to pick those up. On the dendrite, there are these little receptor sites that the neurotransmitters fit in. Think of the analogy of like a key and a lock. And if enough of those locks get unlocked, then the neuron reaches its threshold, and then boom, you get the action potential and you start that whole process. Now, we do have some neurotransmitters that are excitatory, ones that increase the chance of an action potential, and we've talked a lot about those, but do know there actually are some neurotransmitters that are inhibitory. They're trying to slow down the process, the rate of neural firing. And you might think, why in the world would you want to do that? Well, if you've ever been in a moment where, maybe you feel like you're thinking too fast, like you're anxious, you're nervous, and you'd like to kind of calm down, it's those inhibitory neurotransmitters that allow you to do that. So if you've ever felt like, it's just too much going on, you're overstimulated, these are important too. So we need both excitatory and inhibitory. And at any given time, if you have more excitatory neurotransmitters, if you have more of those than the inhibitory that are in the synapse, that's when the threshold's going to get reached and the neuron's going to fire. This is just kind of a blown up picture of a synapse, again, the place where the two neurons meet. On your left here, you got the sending neuron, which has the axon terminal. It's releasing those little red dots there. Looks like candy, but it's not. And then you got the little gap, and then you have the dendrite of this cell here on the right, and these are supposed to be the little receptor sites. So, if a certain number of those fit in, the neuron reaches its threshold, and then it's going to fire. What you may not have heard yet is there's a process. So these neurotransmitters get sent, and then there's a process where the sending neuron says, hey, if you're not going to use all those, I'll totally take them back. It's like you take some snacks to a party, and if people don't eat them, well, I'm going to take them home with me. So the sending neuron sucks back these extra neurotransmitters in a process called reuptake, R-E-U-P, take. So this is important because a lot of the drugs that we're going to learn about later in this course block reuptake, meaning they kind of say, no, you can't take those chips home. And so it forces these neurotransmitters to the next cell, and the overall, outcome of that is that you have more of that neurotransmitter in the brain, but getting a little bit ahead of ourselves. But this is a kind of a blown up image of a synapse here. You got the sending neuron, receiving neuron. You got these little receptor sites. This is just this is an image from your book that just kind of shows you how this is taking place within the context of the action potential and how the two processes, kind of go back and forth and work with one another. Now, you might have seen this chart in your book or in the PowerPoint and just said, oh my gosh, what did I get myself into? You're questioning all of your life's decisions. Do I have to remember all this? Not all of it. I mean, it is a lot, but the good news is, you're going to use this a lot later in the course when we get into our discussion of drugs, not only like the illegal ones, the ones that people use recreationally, but also psychiatric drugs, so like antidepressants and those kind of things. So I'm going to take a few minutes just kind of help you make some sense of this. So There's dozens of these neurotransmitters in your brain. We're just going to focus on about 5 of them. But again, there's a lot more of them. Also, this is a huge oversimplification, the way that they kind of talk about these. So I'm going to try to keep it simple, but just understand that we're kind of in intro to psych, and it gets way more complicated than what we talk about here. So I'll try not to get too in the weeds with you. But anyway, so we'll go through these first 4 or 5. This one here is pronounced acetylcholine. We'll probably just call it ACH. The big things here, muscle action, so allowing for muscle movement, plays a role in learning and memory. And you're probably thinking right off the bat, like, those are 2 very, different things. Like, how does one chemical do 2 things that appear to be so different on the surface? And the thing to remember is that these chemicals are found in several parts of the brain and the nervous system. So, like ACH, you can find it in the brain, but you can also find it in the nerves in your hands and your feet and your legs. And so they can do different things in different parts of the nervous system. So anyway, you got some muscle action, you got learning and memory. If you didn't have enough, an undersupply, that is correlated with, at least, if not proven cause. I'd have to go back and look, but it's a sign of Alzheimer's disease, which again makes sense with the memory there. So they found that people with Alzheimer's disease, the neurons that produce ACH are decayed. They're not working the way that they're supposed to. And so it may not just be the ACH alone. It could also be the neurons too. Dopamine, dopamine. I could do a whole video on dopamine, but I won't do that to you. But basically, movement, learning, the ones I would focus on, attention, so focus. So people with attention deficit disorder oftentimes have an imbalance of dopamine in their brain. You can see here also, it's too much dopamine excess is linked to schizophrenia. And when we talk about schizophrenia, we'll get into the specifics, but there's a direct link between dopamine, having too much, and schizophrenia. And then if you don't have enough of it, that is linked to Parkinson's disease. One other thing that is super important, I don't know why they didn't put this on the chart. Dopamine is also the reward chemical. It's the feel-good chemical, meaning when you do things that are pleasurable, like take a bite of chocolate cake or see someone you're attracted to naked, or get a bunch of notifications on your phone, you get these dopamine spikes. And taking things like illegal drugs can spike dopamine as well. The point is, things that bring you instant gratification and pleasure are linked to dopamine, and there's all kinds of ramifications because of that we will get into later in the course. Serotonin, mood, hunger, sleep. The big one here is going to be mood, because a deficit of serotonin is linked to depression. But again, oversimplification. So is a deficit of dopamine in some instances, as well as the next one, norepinephrine. So again, this is very complicated. But serotonin is the most common neurotransmitter that's linked to depression. Most antidepressant drugs boost serotonin. Again, they can boost others, but serotonin is the most common. Norepinephrine, think of this one generally as adrenaline in your brain. So norepinephrine, not norepinephrine, it's going to control alertness and arousal, so giving you energy. So again, not having enough of this can leave you feeling lethargic and tired, if not, for depression, there's a physical component to depression. You feel physically tired and slow, and if that's one of the symptoms that someone's having, then they would, maybe prescribe a medicine that boosted norepinephrine. This next one here, Gaba, gamma aminobutyric acid, but we'll call it Gaba. This is an inhibitory. We talked about that a little bit ago. They talk about link to seizures and tremors and insomnia, and that's all good. I think they should also mention that this is linked to anxiety. So people that have anxiety disorders often have a deficit of GABA, especially those with like a panic disorder. So anti-anxiety drugs, if you've heard of things like Xanax, they boost GABA levels. Now they only do it for a little bit. They're not a long-term solution, but they work to boost GABA in the brain. You can see this last one here. I don't really have anything cool or interesting to add to it, but know about glutamate. Just do your best with these. We'll do a lot of practice with them. It does take a little bit of rote memorization, but we'll use these a lot as the course goes on. So hopefully as we progress, you'll get them all. Finally, understand that drugs, when we get into talking about drugs, they can work with neurotransmitters in a couple of different ways. And we'll get into this more in the drug video, but they can either be agonists, where they basically trick the brain into thinking there's more of a neurotransmitter, or they can block reuptake. They're still considered to be an agonist. And you can see some examples on the slide of these agonists. And then they can also be antagonists, which basically they can fit, they don't fit perfectly into the receptor site, but they block it enough that the neurotransmitters can't get in. And so the analogy we like to use, I totally stole this from a student too, by the way, is if you're using the analogy of like getting into a bar, the agonist is like a fake ID. It tricks the brain into thinking, ooh, more dopamine. And then the antagonist is going to be the bouncer. It's not going to let somebody in. It's going to stop it. Another way of thinking about agonists and antagonists, an agonist is going to be like a master key that doesn't just turn or open one lock, it opens many locks. So even though it's not the perfect key for that lock, it fits in and it unlocks the lock. The antagonist would be a key. Maybe you've tried this before. You're trying, what key is it? You stick it in and it goes in the door. It goes in the key, but it won't turn it. So that's kind of what an antagonist does. It'll fit inside the lock, but it won't unlock it. But if that key's there, then the other keys, they can't even get in. They're blocked. So that's an antagonist. Again, we'll talk a little bit more about this with the video on drugs later in the course, but that is a quick overview of neurotransmitters. Hopefully in this lesson, it all makes sense. Please bring questions to class. We'll do some practice with it and give you some chances to, figure out anything that's given you trouble. So that's all for now. Thanks, guys.